Greetings, my name is Hardik Raj, and today we will be discussing the problem protecting the poison. This is an easy medium problem, and the prerequisites are greedy, sorting, and segment geometry. This problem was asked in the online pre-elimination round A of SnackDown. So let's see the problem description. Let's look at the problem description first. The kingdom of snakes is an n cross n grid. The most valued possession is a huge collection of poison. So it's a really long story, so I will just give you a gist of what we are required to do. Basically, we are given an n cross n grid. This is an n cross n grid, and here n is odd. This is given. Then we have poison stored in a k cross k grid. It is guaranteed that both n and k are odd. So next we are given a k cross k grid in which some poison is stored. Now we are given the starting position of this poison grid, which is n minus k by 2 plus 1 comma n minus k by 2 plus 1. This is the starting index or the top left corner of the poison grid. So we can calculate what will be the top left, this is top right, this is bottom left, and this is bottom right. We can calculate what will be the positions of these corners. But let's move on to the question. But there are thieves who want to steal the poison. They cannot enter the n cross n grid, but they can shoot arrows from the outside. So now we have thieves. We have thieves over everywhere. Like this. So everywhere there are thieves. Okay, and they shoot arrows. These arrows travel across a row from left to right or right to left, and across a column from top to bottom or bottom to top in a straight line. Straight line is important. So each of these thieves can either shoot an arrow like this, or an arrow like this, an arrow like this, an arrow like this. So they can shoot straight arrows from either in this direction, this, or this direction. Okay, now it has gotten a little messy. Let's clear it up. If the arrow enters the k cross k grid, some of the poison will stick to the arrow and it will exit. And if it exits the n cross n grid after that, the thieves will have successfully stole some of the poison. So if the thieves shoot an arrow which enters and exits this k cross k grid and then further exits this n cross n grid, then the poison is supposed to be stolen. As the king of the snakes, you want to thwart these attempts. You know that the arrows will break and stop if they hit a snake's scaly skin, but won't hurt the snakes. There are some snakes already guarding the poison. Each snake occupies some consecutive cells in a straight line in the n cross n grid. This is important. Basically, where did it go? Yeah. So now we have some snakes, and there are two important characteristics of these snakes. First, they lie in a straight line, either in the horizontal direction or in the vertical direction. And if the arrow hits a snake, then the arrow breaks. That is, it won't pass through the snake and it won't kill the snake. So there are three things. Okay, so the snakes, there are three important things to consider. The arrows don't kill the snake. Arrows break on contact with the snake. So, okay, let's leave it like that. And the snakes are lying either either horizontally or vertically and not diagonally. That is, they're either lying like this, or like this, but not this. This is important. Okay, so now that we know the arrangement of snakes, let's move on to the problem description. Okay, and yes, but won't hurt the snake. Each snake occupies some consecutive cells in a straight line inside the n cross n grid. That basically means that no snake is lying outside the grid. They are either a part of row or part of column. Note that there can be intersections between the snakes. Okay, this is important. That is, two snakes can lie like this. This is one snake, then this can be some another snake, then this can be one more snake, then there can be one more snake like this. So basically, the snakes can intersect each other and they won't eat each other. A configuration of a snake is safe if the thieves cannot steal poison. That is, no matter which row or column they shoot arrows from, either the arrow should hit the snake and stop. This can happen even after it has entered and exited the K cross K grid, or it shouldn't even enter the K cross K grid. So this is a K cross K grid, and suppose a snake is lying over here. Then the poison is considered protected if an arrow hits the snake and drops, or if it comes from the other side, takes the poison with it, again hits the snake and drops. In both of these conditions, the poison is considered safe. The king has other duties for the snake and hence wants to remove as many snakes as possible from this configuration such that remaining configuration is still safe. Help him find the number of snakes he needs to leave behind to protect the poison. So we want to minimize the number of snakes guarding the poison such that the poison is guarded. And there may be case that it is not possible to guard the poison, and in such a case we output -1. Let's look at some examples. Let's look at the example given in the question. We can, if we try to shoot an arrow from here, this blue snake is protected. If we try shooting the arrow from here, the purple snake is protected. If we try shooting an arrow from here, the green snake is protected. And shooting an arrow from here makes no sense because we want to steal a poison. So we will try to shoot from this region, this, and then this, okay, and not this one because we want to take the poisons. So we should shoot in that area which contains the poison. So here we can see that the poison is always protected. Okay, now let's look at the other example. Okay, but before moving on to the second example, let's look at what is the minimum number of snakes that we can have. So let's erase these arrows. Okay. One thing to notice is a horizontal arrow. While shooting a horizontal arrow, we don't care about this region, right? Because any snake which is positioned like this horizontally or over here doesn't actually help us. So if we are shooting an arrow in this region, any arrow which belongs to either this region or this region is totally useless. And the same can be said for when we are shooting an arrow from here. So all the arrows which are uh, in this region and in this region are basically useless, and the snakes which are over here and over here are useful. This is important and you will understand why. Okay, so now we are going to shoot an arrow. Right, let's try shooting an arrow from here. So we see that if we want to protect this region, then what we can do is, if we want to protect something like this, then we can simply keep this snake over here, this huge green snake. And by doing this, we can remove this snake, and this orange, this purple snake. This green snake will handle all the arrows if they are coming either from this side, that is the left to right, or from right to left. Okay, now what if we are concerned about arrows this, like this? So till now we have removed this snake. Okay, wait, let me use a darker color. We have removed this snake, we have removed this snake, and we have removed this snake. Remaining snakes are this red snake, this blue snake, and this yellow snake. So we see that we have to keep this red snake to protect an arrow from this side, right? So this snake is important, so we have to keep this snake. And as for this snake, that is this blue or this yellow snake, we can keep either of those because then they will protect this boundary. So let's say we kept the blue snake and removed the yellow snake. So the total number of snakes that we need is this one green snake, this one blue snake, and this one red snake. So the total number of snakes is 3. This was for the first example. Now let's move on to the second example. Now let's look at the second example. Again, we'll start shooting from the horizontal side. So we try shooting it from here. This is exactly like the first situation. So we can remove this pink snake, this blue snake, and this purple snake, and just keep this long green snake. Now let's try shooting from top to bottom or bottom to top. Now here, see, this region will always be unprotected, and so the thieves can always steal the poison by shooting from this side, and hence we cannot do anything, and the answer is -1. Some of you might be wondering, why not just move this snake over here by one side? But this is not an allowed operation. We are only allowed to delete snakes. Sorry, delete, not delete, just remove them from the duty. This is this purple snake was on duty, so we just removed this snake from his duty, and the snake king will find him some other duty. Okay, yeah. So basically, we are not allowed to move the snakes. We are only allowed to remove the snakes, and hence, in this case, we cannot protect the poison, and so the answer is -1. Let's list down our findings. Okay, now let's look at our findings. Each snake can be placed horizontally or vertically, but not diagonally, given in the question. We cannot move the snakes, we can only remove them, again given in the question. The horizontal and vertical sections are independent. This is something that we observed while looking at the samples. And fourth, we want to minimize the number of snakes. Again, this is given in the question. Let's just look at point number 3 for once. So we had our n cross n grid, and within that we had a k cross k grid. We know that the arrows can be shot either horizontally or vertically. For vertical arrows, the snakes which are lying over here, like this or this, they are of no use. We only want snakes which are present in this section, or at least some part of them are present in this section. Let's say the snake is like this, then this snake is important to us. But if a snake lies like this, then while considering the vertical section, we have no use for this snake. Similarly, let's say we are shooting arrows horizontally, like this. Then the snakes which are lying like this, or this, or this, are of no use to us. The snakes which are lying over here, either horizontally or vertically, they are of importance to us. And even if some part of them is occupying a region, they are of importance to us. So this is important, this is important, this, and rest are unimportant. Now let's move on to the solution. Now that we know that we can divide the problem into either horizontal sections or vertical sections, and then the result will be the sum of those two. So for now, I will be only solving for one of those sections, and the same logic will be used for the other section. So let's say that this is a k cross k grid. Okay. Now we want the snakes whose some part, either fully or partially, they cover our horizontal section, that is, sorry, this vertical section. So this snake, then we have again this snake, then we have this snake, then this snake. Okay. And similarly, if we are considering this section, like this section, so we want snakes whose some part occupies this section, like this, 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 this. But snakes like this, 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 and this, they are not at all useful. And one more thing, I think I forgot to mention it, that none of these snakes lie in the poisoned region. So no part of snake will lie in this region. Okay, no part of snake will lie in this region. All right. Now, having understood this, let's try to build a solution. This is a very important observation, that we can just split these snakes in either horizontal or vertical. For better understanding, I will be considering this section. So we can just remove the vertical sides. Okay. And now we want to select snakes such that they will occupy this region, that is the, let's call this region as top left, top right, bottom left, and bottom right. Okay. The top left has coordinates n minus k by 2 plus 1 comma n minus 2 by n minus k by 2 plus 1. This is our top left corner. And for the top right, we just need to add this k in the second argument. So for top right, this will become as n minus k by 2 plus 1 comma n minus k by 2 plus 1 plus, what is this length? This is just, we need to add k minus 1. Since k is the length, we add k minus 1. This is important. We don't add k, we add k minus 1. I think just ponder over this, why we are adding k minus 1 and not k, because explaining this will deviate us. Okay, now moving on. Bottom left. This will have n minus k by 2 plus 1 plus k minus 1, comma, n minus k by 2 plus 1. Okay, this is our bottom left. And for bottom right, for bottom left, we simply needed to add this k. So hence we added k minus 1, and for bottom right, we need to traverse k over here and k over here. So the bottom right will be n minus k by 2 plus 1 plus k minus 1, comma, n minus k by 2 plus 1 plus k minus 1. Okay, so these are the coordinates. We won't be needing them for now, so I will just remove them. Okay, now we have some snakes which are lying like this, this, and this. Notice one thing. Okay, uh, wait, we need those coordinates. Notice one thing, that for top left and bottom left, the second argument is same, and for top right and bottom right, again the second argument is same. So let's say the snakes are lying like this. This should be a straight line. Okay, like this, and this. So we want snakes that cover this region. Okay, so basically, since the second coordinates are same, we say that we are given a line segment, and we are given some additional line segments which are snakes. We don't care about their first coordinate because we want them to cover this horizontal segment. So it doesn't matter if the snakes are up or down. As long as they cover this horizontal section, they will be useful to us. Okay. So yeah. So this question now converts to, we are given a horizontal segment ranging from top left to top right, or bottom left to bottom right, or more precisely from uh, n minus k by 2 plus 1 to n minus k by 2 plus 1 plus k minus 1. This is our horizontal segment, and we are given some more segments like a1 b1, a2 b2, a3 b3, a4 b4. And what we want to do is, we want to merge these segments, that is AI BI segment, in a larger segment, that is, sorry, we want to merge these AI BI segments so that it covers this segment, the given segment. So this is a pretty common way to do it. I think I'm going in circles, but I will explain it through an example. And this is a pretty common question. You should guys know about this. Let's say we are given a segment from 1 to 10. This is our segment 1. This is our segment, and we are given some smaller segments like this. Okay, then another segment might be like this, and another segment might be like this. So we just want to answer the query that if we were to merge these segments, the blue segments, and by merge I don't mean that, since let's call them first segment, second segment, and third segment. Since there is a common point between the first and second segment, these can be merged. But there's no common point between the second and third segment, so they cannot be merged. But if we were to add one more segment like this, so there's a common intersection between second segment and fourth segment. So we could have merged second segment and fourth segment, and since there was a common intersection between fourth segment and third segment, we could have merged fourth and third segment also. So the resulting segment would have been like this, from here to here. And we wanted to answer the question that if we were to merge the blue segments, then will it fully cover this red segment or not? So yeah, we just want to answer that. Let's look at the code to understand how we are going to find if the blue segment superimposes or basically covers the red segment or not. So let's first take, or you know what, I will explain this code later on. Let's try to understand this code first. So this vector of pair of int comma int, this is basically the blue segment, or the coordinates, it is the blue segment. So the first argument basically denotes what is the left side of the blue segment, and the second argument denotes what is the right side of the blue segment. So I will just write it over here. That is array of I dot first. This is the left side of blue segment, or basically a of I, and array of I dot second. This is the right side of blue segment, or b of I. I'll just show you once more that this is what we were referring. See, a1, b1, a2, b2. So these are the left and right segments. Okay, and this int l comma r, this is the right segment. That is, l corresponds to this address or this coordinate, and the r corresponds to this coordinate. Okay, so first of all, we sort our given segments on the basis of their left endpoints. This is a custom comparator which is necessary when we are sorting an array of pairs. So this will sort it on the basis of that segment. So let's say that our segments were like this. Our input array, that is ARR, was 3, 4, 5, 6, 2, 3, and 1, 8. Okay. So the sorted segments will be 1, 8, 2, 3, 3, 4, and then 5, 6. All right. And what we want to do is we want to merge these segments and check whether or not this merged segments covered the right segment or not. Okay. So let's mark the starting segment that we want to cover as next left. So let's say, in this example only. Right now, next left is 1. Okay, and we want to cover this one. Or wait, let me find a better way to phrase this. So we will have some segments on left side also, right? Okay, so and we want to cover this whole segment, this whole right segment, without leaving any gaps. Wait, let me erase this. Okay, yeah. So let's look at our left segment. So this is our next left. Since we want to cover the whole right segment, the best way to do is from left to right. So we start iterating the array segment from left to right and we check. Okay, uh, if we were to select this starting point, then what is the maximum right that we can cover? Let's say that there was one more segment over here. Then you can see that selecting this segment would have done us no good because this does not cover any any of the required red segments, right? But if there was this blue segment which was starting earlier and it was extending more than this segment, then it would have made sense to take this segment because this is covering more of the red regions. But let's say that this blue segment was starting here and it ended over here, then in this case it would have made sense to pick this blue segment because this is covering more of the red segments. So we are doing greedy picks. And as for next left, it denotes what is the next segment that you want to cover. Okay, and int count. This is a final count of snakes that you want to retain. And int max right. Okay, what is max right? This basically tells us what is the maximum right segment that we are covering right now. And since we are not covering any right segment right now, we initialize it with -1. Okay, and int I equal to 0. This iterating variable will help us iterate over this array, the array of segments, and this is already sorted. Int sz, which is the size of the sorted array. Now let's move on to this loop. So while I is less than sz, so that we don't run out of segments, and this while next is left and equal to right. So what was next left? This was the next left basically told us that till before next left we have covered all the red segments and we want to cover the red segments after that, that is basically starting from the next left. So if our next left becomes greater than our right, so if our next left is here, so basically that means that we have covered all the left segments and it makes no sense to keep on looking for more snakes to cover the red segments. This is a little confusing, but this is a very standard algorithm and I want you to understand it really carefully. Okay, now array of I dot first. This is our current left. That is, this is our A of I. Should I write it? Yeah, let's just write it. Array of I dot first is basically A of I. And we check if our A of I, that is the left endpoint of our blue segment, is less than or equal to next left. So it is this case that our next left is over here and these are our A of I. So in this case, we want to select that blue segment which gives us the maximum number of coverage over red segments. So we check if the max right. So we update a max right, that is the maximum possible number of red segments that we are covering by this, and then we move on. So this was this case that let's say the next left was here, we would have covered all this region till before next left, and say our starting segment was somewhere over here, then we would have selected that starting segment which would have given us the maximum coverage. Okay. Okay, now this was the case when our starting the left endpoint was before the next left. So that meant that we could have still covered some right segments. Okay, but what if on the left segment is over here? Okay, so let's say we calculated whatever we could have done with these segments and now we are looking at this segment. Forget about these. So this was a required next left. So it basically meant that we had covered everything till here. Now, if our current left, that is our current A of I, exceeds this next left, then, and there was some uncovered red regions, then in this case the answer won't exist and we should output -1. Okay, so how to code this? So that is our A of I is now greater than our next left. So we check if the regions after next left was covered or not. Since let's say we took this starting point, this one, then this would have covered everything till here, and we would have been left with these red segments to cover. But let's say that there was one segment which was starting over here and which ended at just next left, and now we are looking at A of I over here. Then in this case we would not have covered anything in this region, and so we output -1. But what if we would have covered everything till at least over here, that is our current A of I, you would have covered till here, and maybe some more regions, we don't care about that, but as long as we cover till here, and this is our max right. What is the maximum red areas are we covering? And next left is, we are definitely sure that we have covered everything till before next left. Yeah. So if our max right is greater than or equal to next left, so basically uh, we have covered some regions uh, post next left. Okay, then in that case we want to select that snake which has made it possible. So in this case this is a snake that we want to select, and then our next left would be what, this was a max right. So basically we have covered everything till here, and so we want to move, we want to cover everything from this position on. So our next left would be max right +1, and now we set max right to -1. Why is that? So okay, it's quite difficult. Don't worry if you're not understanding it. We then initialize max right to -1 to indicate that we are starting the process from the beginning. We can say that we have covered everything till over here, and we will start the same process from this endpoint or this point. So this will be our next left, and we will repeat the process. So this is what this code does. When we output, when we come out of the loop, we still need to make sure that everything is covered or not. What if our segments ended till here and we still needed to know if this region is covered or not? So we will check if any segment which is over here is covering the possible regions, the remaining red regions or not. And if it is, then we select that snake and we increment and next left equal to max right +1. Now, if a next left, remember what is next left? Uh, it basically means that we have covered everything till before next left, and we want to start covering from next left onwards. So if our next left is less than or equal to r, that is we were not able to cover some regions. In this case, we output -1. Else we return the number of snakes. Okay, now that we know what this find min function is, it basically returns the minimum number of snakes to guard either the poison from either the horizontal arrows or from the vertical arrows. Okay, now let's look at a solve function. Basically, I take the input, the number of test cases over here in t, And for each test case, I call this solve function. Int nkm, n is the n cross n grid, k is for the k cross k grid, and m is the number of snakes. Here I'm calculating the corners of the k cross k grid square, and which I already told you before. For easy understanding, I will be using a comma b, c comma b, a comma d, and c comma d. What are these? Let's look at this k cross k grid. Here, the top left has coordinates a comma b, the top right has c comma d, c comma b. The bottom left coordinate has coordinates a comma d, and the bottom right corner has coordinates c and d. Okay. Now, this vector of pair of type int comment horizontal and vertical. The horizontal, so the horizontal array, it basically stores those snakes which will be used for protecting our poison from the horizontal arrows, like the arrows coming from here and here. So all those snakes like which are lying like this or this, they will be used for they will be in the horizontal section. Now, same for vertical section. The arrows which are coming from this direction. Then the snakes which will be guarding these vertical arrows or the poison from these vertical arrows will be stored over here. Okay. Okay. So now that we understand what is the horizontal and the vertical array or basically pair, now let's look at the rest of the code. We have to take input of m snakes. Here x1, y1 and x2, y2 are the coordinates of the snake. This is just a simplification. Basically what I am saying is if a snake is horizontal or vertical, then x1 comma y1, and in case of horizontal the y coordinates remain the same, and so x2 is greater than or equal to x1, and similarly y2 is greater than or equal to y1. x1 y1 and x1 y2. So I'm saying that the second coordinate, that is x2 as well as y2, they are greater than the first coordinate. It's just a simplification. You guys don't need to follow this, but I'm just using this. Okay. Now, now we need to know which snake lies. Now we need to know if a snake protects the horizontal poison or the vertical poison. So let's let's say that this is a grid. Okay, and if this was top left, that is a comma b, this was top right, c comma b, this was bottom left, a comma d, and this was bottom right, c comma d. Okay, so if the arrows are horizontal, let's look at the case of horizontal arrows, right? So which snake will protect this? If a snake lies here or here or here, 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 here. So these types of snakes are not at all useful when the arrows are shot horizontally. So the type of snakes that are useful in protecting are like something like this. Okay, let's say x1, y1, and x2, y2. In this case, y1 is equal to y2, or let's say that a snake was here. Okay, x1, y1. So as long as its tail is less than b, as long as its tail is less than b, this won't protect us from the horizontal arrows, right? So we need to keep on extending it till we reach b. So we know, or we can conclude one thing, that if the tail lies below B, then that snake would be helpful in protecting from the horizontal arrows. But is that the only condition? Well, let's look at this snake. For this snake, the y2 coordinate is greater than b, but it is still useless, right? It is not protecting anything. So we should extend its head until it reaches D. Okay, so as long as its head will go above this line, so it will be useful in protecting the poison. So just to reiterate, let's say that the second coordinate of this is y1 and the of the tail is y2. So basically, if y2 is greater than equal to b and y1 is less than equal to d, if both of these conditions are satisfied, then the snake will be helpful in protecting the poison. So that is what I have done. If both of these conditions here, this is b. As you can see, top left dot second was b and top right dot second was also b. Wait, what? Top right dot second. Wait. Is something wrong over here? Okay. We know that y2 should be greater than equal to b and y1 should be less than equal to d. And what is d? D is bottom left or bottom right. It should actually be bottom right dot second. Bottom right dot second. If both of these conditions are satisfied, then this snake will be helpful in protecting the poison being stolen from the horizontal arrows. Now let's look at the vertical condition. If the arrows are shot vertically, let me just erase this. We don't need this. Okay, yeah. So now that arrows are being shot vertically. Okay. So the type of snakes that are useless are snakes like these, right? And the snakes that are useful, even this is a useless snake. This is also a useless snake. But the type of snake that is useful is either like this or this. These are the useful snakes. So what makes a snake useful for vertical arrow? Well, as long as let's define a boundary of some sort. Okay, as long as the endpoints of the snake, that is, let's say this is the head and this is the tail. This is x1 and this will be x2. We don't care about the second coordinate because we are only looking at the horizontal section. That is, we are looking at the vertical arrows and we know that the snakes will either be like this or they might be a point snake. Or even if they are like this, we can consider them to be a point snake. Okay. Well, should I just tell you why we can consider it as a point snake? Well, say this is a snake. Okay, this is a snake. And if a vertical arrow comes from here or here, then the snake will protect the poison, right? But what if the snake was just like this? Then also it would have protected, right? So we can say that in case of vertical arrows, we can consider vertical snakes as point snakes. And the coordinates would have been x1, comma y1, and let's say x1, comma y2, and x1, comma y3. we don't care about the second coordinates at all. This is also true in case of horizontal arrows. It's just that I forgot to mention over there, but yeah, that is what we are doing. We, in case of vertical arrows, we only consider about the x coordinates, and in case of horizontal arrows, we only care about the y coordinates. Okay. Now coming back to how to consider if a snake is useful or not, we just see if, let's start over. Okay, let's say the snake was lying over here. This is x2, this is x1. So this is a useless snake. But if we were to push this head over here, something like this. So if it hits this boundary, then this snake would be helpful in protecting the poison. So one condition is that x1 should be less than or equal to c. Similarly, if is it only the condition, because if a snake is like this at x1 x2, here also x1 is less than or equal to c, but still this snake is useless. So we have to extend its tail until it reaches a. Okay, so x2 should be greater than or equal to a. If both of these conditions are satisfied, then that means the snake is at least partially covering the vertical arrows, and so the snake is useful. And that is what we are doing over here. x2 is greater than or equal to top left dot first. What is top left dot first? Top left dot first, which is a. So x2 should be greater than or equal to a. And x1 is less than or equal to bottom right dot first. What is bottom right dot first? Bottom right dot first is c. Yeah, so x1 should be less than or equal to c, as we derived over here. If that is the case, this snake is useful in protecting us from vertical arrows, and we we concern ourselves only with the first coordinate, as I've already mentioned before. So this is how we categorize the snakes, and here we just call in the results for the number of horizontal snakes and the number of vertical snakes. Or wait, sorry, horizontal and vertical. Okay, so res horizontal, this basically stores minimum number of snakes required to protect from horizontal arrows, and similarly res vertical, it is the minimum number of snakes required to protect from vertical arrows. Okay, and if either of these functions return -1, so then that means that region will be unprotected no matter what, and so we have -1, else we return the total result. Okay, so let's try submitting this. Click on submit. Okay, yeah, so the solution was accepted. Now let's look at time complexity. Okay, so for each test case we are taking input. Okay, fine, and these are all constant time operations. Since n and k are given, simple division operation and addition, this does not take any time, so all this is O of 1. I just write all the above process is O of 1. Okay, now swapping also takes O of 1 time complexity, that is it takes constant time to swap two numbers. Okay, pushing into the array also takes constant time. Now let's look at the find min function. So for the find min function, we are first sorting the array. So this takes O of n log n, where n is the size of the array. N is size of the array. Okay, and fine. And then here we are iterating over here, and we are iterating till we reach at the till we iterate over the whole array. Okay, so this is basically O of n. In this, all of these operations take constant time only, and this is also constant time. So find min function, it basically takes O of n log n for sorting plus another O of n for the iteration over the array. So the total time complexity is O of t into n log n plus n. This is the total time complexity. So I hope you understood the solution, and see you next time. That's it, folks. This problem was a practice problem to help you upscaling your SnackDown journey. SnackDown is a highly competitive global programming event where coders across the globe participate under the same roof. Participating in such an event would not only be a proud moment for you, but it will also help you interact and learn from coders across the globe. This is an opportunity you do not want to miss. So keep practicing and go check out other problems in the mock contest. See you next time.